Good morning, class. Excuse me. This is Mr. Eggleston, and this is lesson 3.3, Solving Linear Equations by Balancing for Algebra 1P. All right, I want to begin by going over the learning targets. It says the learning targets are to write linear equations that can be solved to find missing information about a situation. It's a lot of fancy talk for saying being able to write equations that can be solved for the missing for what you're trying to figure out. All right, distinguish between variable terms and constant terms of a linear equation. So what does that mean? Well, a linear equation could be this: 2x plus 5 equals 25. All right, so let's say that's the equation. The variable term is, by saying it's the variable term, is the term that has a variable attached. So the variable term, and I'm just preloading this so that we don't have to spend time on variable. Variable term is 2x. The constant term is 5. You could also make an argument that constant term is also 25 in this equation. All right, but we're just looking at the thing holding hands with the variable. So that's also constant term. So basically, we're breaking down the left side of this equation. And then we're going to understand each part of a linear equation in context. And what do they mean by context? An actual situation. They do a lot of these context problems, or trying to get you to understand the context of an equation, where it comes from a given problem that will make sense. And then we'll abstract it to an equation and just giving you linear equations to solve. Understand each part of a linear equation in context and use this context to isolate the desired value. All right, so first off, here's the word problem. The covered up stuff on the left will be the things that when we review, these would be the margin notes when I start writing it abstractly. Okay, every year Tiffany and her twin brother Todd gets gifts from their grandmother for their birthday. This year, Tiffany's card had a $20 bill. All right, so Tiffany's card in it and 2 Visa gift cards. Todd's card had $35 in cash and 1 Visa gift card. The first question really is your personal opinion. Just be able to verbalize it. Would you rather receive Tiffany's gift or Todd's gift? Why? I guess that has to do with, would you rather have more cash up front and less gift cards, or less cash in front and then 2 gift cards? And why? Okay. You may realize that it all depends on it's your personal opinion, but a lot of this depends on how much each gift card is worth. So we don't know that yet. We just know you got a gift card. Tiffany got a gift card and $20, and Todd got $35 and 1 Visa gift card. I personally would probably rather go for the cash. So I probably would want Todd's gift because that gives me $15 more than in cash than Tiffany's. All right, but you write down what you think and why. Tiffany complains that the gifts aren't fair. Do you agree with her? Why or why not? Again, this is a statement or a question that really depends on how much each gift card is worth. Are they the same gift cards? Are both the gift cards that Tiffany got and the gift cards that Todd has, are they of the same value? They don't really say any of that, so this is really open-ended. I personally don't think Tiffany got swindled or it wasn't fair because, hey, I'm a guy and I was my grandmother's favorite, so I see the $35 as being more than my sister, so that makes me happy. Okay, again, that's pretty open-ended. Okay, now here's the crux. Tiffany's grandma says that their gifts have equal value. Okay, assuming each gift card, this is an assumption now. Some of the stuff I said earlier, you're making assumptions. Assuming each gift card has the same amount of money on it. They're the same, like denomination, like a $10 Starbucks card. So, what must be the value of the Visa gift card? Since we don't know, how do you know? So, this is where you can try and figure it out. All right, so again, pause and you should answer these. And then watch the video to see how I did it and my reasoning. And see if we get the same values. So go ahead and pause the video and try it. All right, so Tiffany's grandma says that the gifts have equal value. So let's go back up, and we see that Tiffany's card had $20. So we have two things. We have Tiffany, Tiff, and Todd. Tiff had 20 and 2 gift cards. I'll call them 2C. C for cards. Okay, C equals value of a card. And then Todd had 35 and 1 gift card. I'll go ahead and put the 1 in front of the C to emphasize it's 1 gift card. But really, we don't need the 1. We could just be 35 plus C. So just be aware. And since Grandma says that the gifts have equal value, they're worth the same amount, there's an equal sign between them. Well, when you look at this, you can see that Todd has $15 more, right? $15 more than Tiff. But Tiff has 1 more card. And just by that reasoning, you can see that 1 card must be $15. So each card is worth $15. All right. And how do I know? Because it balances out. Both Tiff is short for Tiffany, and Todd's gifts. Okay. Now, question 4. The following year, this is a completely new year and a completely new setup. Tiffany gets $25. So the same thing, I'm going to have Tiff on one side and Todd on the other. And I'm pretty sure Grammy, or their grandmother, assures them that she spent the same amount on each gift. So it's worth the same amount, okay? What is the price of a box of candy? So Tiffany gets $25 plus 1 box of candy plus 1 C. C, value of candy. So C equals value of candy. And Todd gets 20, let's see. Tiff 25, and then Todd gets $20 plus 5 boxes of candy. Personally, I'd rather have more of the cash than the candy, but that's a personal preference. All right. What is the price of each box of candy if they are equal? Well, do you agree that Tiff got $5 more? Right? You got 25 in cash and Todd got 20 in cash. So Tiff got $5 more in candy, but Todd got 4 boxes more, right? Because you got one box here, 5 boxes here. So Todd got $5 less, but 4 more boxes of candy. So that tells you 5 must equal 4C. So C would just be 5 divided by 4, which is 1.25. So each box of candy costs $1.25. Okay. The year after, Tiffany got $15 and 2 pairs of socks. Okay, so again, it's the same setup. Tiff had $15 plus 2P for pairs of socks. So P equals cost or price of socks. Okay. And then Todd gets $10. Oops, I said 18. Wrong. $10 plus 2 pairs of socks. All right. So, is it possible for both to be given the same worth of things if the price of cost of socks were the same? So that's the question. Can these ever be equal? Okay. Well, I hope you realize that 2 pairs of socks are given to both and they kind of just go away. And you're left with Tiffany getting $15 and Todd getting $10. And there's no way that these 2 gifts are worth the same. There's just no way. No way for the gifts to be worth the same. Okay. Okay, because 15 does not equal 10. Matter of fact, it kind of proves that Tiffany got a better deal here because she got $5 more. Now, don't discount pairs of socks as gifts because when you get older like I am, you realize nothing beats a good pair of socks. All right? Let's go back and do some margin notes. So the first thing was that if I let X equal the value of Visa gift card, then this setup becomes this. Tiffany would be 20 plus 2X. Todd would be 35 plus X. This is now abstracting it into letters and an equation that we can solve. And, all right, so if that's the case, we just set them both equal. So, sorry about that. Boom. So 20 plus 2X must equal 35 plus X. And basically, we saw that if we subtracted 20 from, this is these steps, right? We balanced it up by subtracting 20 from both sides. You got 2X equals 15 plus X. Oh, plus X. Notice I'm just going to say X and not 1X. Then if I subtract X from both sides, gain the variables to the same side, you end up with X equals 15. That's the abstract way of solving this. We first just reasoned it out. Okay, so this is trying to get you to understand how you can reason things out. Okay, so now here on this one it says that her gifts have equal value. And so you have this. Now, this is a bar model. I'm not a huge fan of it because I don't know how useful it is. Maybe you might like it. But basically, you diagram each side of the equation. You got the 20, and then you have 2 X's here. You're saying equal, so you see that the length is the equality of it. So they're the same length. They are equal. All right. Now we have, on the other side, we have 35. This is 35. Sorry about that. I broke 35 to be 20, which lines up with this 20, so they are on top of each other. And then a 15 and an X. So you see both those X's are taken care of. And what's left is X and 5. Or 15, excuse me, that's a 15. So that's a visual way you could think about it. All right, use it if you like it. Personally, I'm not huge on it, but if it works for you, great. It's all about trying to solve. All right, the next one is just the equation, right? 25 plus x equals 20 plus 5x. And there's $5 more on the left, but 4 boxes more on the right. So if 4 boxes equals 5, 1 box must be 5 divided by 4, which is 1.25. Okay, so pretty much what I did here, what I showed here. The year after, come on, there we go, is 15 plus 2x equals 10 plus 2x. Well, obviously, there's $5 more on the left right here, okay, but they have no extra socks. So the left side is always $5 more than the right. It's impossible for them ever to be equal. Here's the bar model that can kind of represent that, right? They're supposed to be the same length out here. So we have x, same length, same size, x, again, same size. Now we have 15, and we have 10 here. We're missing 5 to make it equal. So they're not equal, and there's no way it could ever be equal. Again, use the bar model if you like it. I'm kind of hit and miss on it. I guess I've been doing this so long, I don't need the visual of it. And so I find it cumbersome. All right, here are the learning target, the quick notes. Copy them down, pause the video, and copy this. All right. Now, learning target number 1, in order for an equation to be balanced, the difference in the constant terms must be made up for by the difference in the variable terms. If they are not made up for, like we saw in the last question up here, then there's no way it could ever be equal. It's impossible. So, but that's what it means for an equation to be balanced. The solution to an equation, the second learning target, right here, is basically the value of the variable that makes both sides equal to each other. It equalizes the two expressions. And the third learning target is just about the visual way you could think about it. Again, don't kill yourself or don't feel bad if this doesn't make sense. I don't use it, but I've been doing this forever. It wasn't shown to me when I was your age, so, that's why I was successful, was because I could see it, I guess. All right. But anyway, so now do the check your understanding. Okay. Pause the video and see if you can just do it before I show you my answer. So pause. Welcome back. Let's say Kylan and Avi are at a summer carnival. Kylan buys 8 raffle tickets. Avi buys ice cream for $3.50, so they tell you how much of his money he spends for ice cream, $3.50, and 6 raffle tickets. They both end up spending the same amount of money. That's the key. So what is the cost of a raffle ticket? Well, you have 2 raffle tickets, right? Kaylin buys 8 raffle tickets, and Avi buys $3.50 of ice cream, and then 6 raffle tickets. So if they're both equal, that means 8, 6, that 2 raffle tickets must be worth the cost of the ice cream. So 2 raffle tickets must be must be equal to the $3.50. So if 2 raffle tickets are that, 1 raffle ticket is $1.75. Okay. All right, algebraically, you write this. You can write this. Then you would subtract 6x from both sides, and you get $3.50. This is the step-by-step procedure. Then divide by 2, you get $1.75. Both ways give you the same answer. Okay, answering number 2, 2 kayaking companies offer kayak tours. Company A charges $30 to rent the kayak. And sorry about the interruption. And $4 for each hour spent on the water. Company B charges $25 to rent the kayak and $5 for each hour spent on the water. How many hours would you have to be on the water so that the price at both companies is the same. If the prices are the same and X is the number of hours, you could have used H. I just opted for X. Company A charges the 30, which is this, right? This is 30. That's the initial fee, plus $4 for each hour. That's why it's 4 times X. All right? 4 is the hourly rate for Company A. On the other hand, Company B only charges $25 for the initial rental plus $5 an hour. So it's a more expensive hourly rate, but less upfront cash. The question is, how many hours would you have to rent the boats so that they would be worth the same amount? So basically, the idea here is you find the difference in the variables. So you have 4x and 5x. The difference there is 1x. And then find the difference in 25 and 30, which is 5. So that tells you x must be 5. This is just thinking about it, all right? This is using logic. Thus, you would have to, take 5 hours before both both kayaks will cost the same. Now, obviously, that does not incorporate if the kayaks at one place is better than the kayaks at the other, nor does it indicate if there's like extra stuff that one company does over the other, like the one that's more upfront might make sure you are given plenty of stuff, maybe food, water, stuff like that. We're assuming that everything's the same about the kayaks, I guess. All right? So it would be 5 hours before have to be on the water so that the price of both companies is the same. Which would be more expensive after 5 hours? So let's say 6 hours. So you would have 30 plus, this is not part of the question, but this would be 30 plus 25. So for 6 hours, B would be 30 plus 25 is $55, and A would be 4 times 6 is 24, so 30 plus 24 is $54. So Company A, if you go more than 5 hours, Company A will end up being cheaper because the hourly rate makes up for the difference in the initial cost. Okay? So just, ways you can reason with this. Okay, question 3. Consider the equation negative 3x plus 27 equals 8x plus 5. Compare the value of the variable term. So you got negative 3x on one side. You got 8x on the other side. The difference between them, that's what the triangle means. The difference is 11x, right? You have to go plus 3 to get to 0 here, and then that 8 makes it 11x. So you have 11x more on the right than on the left. Okay. Compare the value of the constant terms. Well, 27 on the left and 5 on the right. The difference is 22. So that means that the left has $22 more than the right. Okay. So we have 22 must equal the 11x difference. So divide by 11 and you get x equals 2. So x equals 2 will make the equations equal. That's the way you can think about it. Now, there are step-by-step, and we're going to get into that in a couple more sections, where it's step-by-step. What do you do? And in the warm-ups that I'm giving you, you'll do them in class, and then we'll go over them, and that's when I start really focusing on step-by-step how you can go about solving more complicated equations. So anyway, that is lesson 3.3. Okay? So have a great day. Bye-bye.